right, here we are, iOS Decal lecture number 7. In this lecture, we're going to be talking about REST APIs, which is a really cool and powerful topic throughout software engineering, as well as wireframing, which is going to be really important going into your final projects. Speaking of final projects, the final project is here. Check out the spec on the website for more info. And also in this spec is a area to make an appointment. You're going to make an appointment with a TA or facilitator sometime this week. We each have put different appointment slots up on that spec. So go ahead and go there and sign up for one if one is available. And before your appointment, please fill out the project proposal form also on that spec. This project proposal form is going to be where you propose an idea for your final project, as well as sketch out a little, lo-fi prototype. So just a couple of the screens of the app, something that you have in mind. So it's going to be a sketch and your idea. Please fill this out before your appointment. Again, all this is reiterated in that spec. Currently, you should be coming up with ideas for your final project. That is the phase that we are in. That and also forming your teams. You are going to have to do both of these things before making your appointment this week. And again, we also have a Piazza post open for to help you guys make those teams. Anyways, check out the spec for more info about the final project. Exciting time, and it should be a lot of fun. Speaking of that, the final showcase will still be happening on Monday, May 4th from 12 to 2 p.m. over Zoom. We are going to figure out all of the logistics for this in a little bit, but hopefully we can still get a lot of the really cool people that we wanted to come see you guys in person. Hopefully we can get them to call in over Zoom instead. Sampler labs will also start today. Hopefully by now there should have been a Piazza post made with more details about that. But basically all the sampler labs are going to simply build off of the lecture demos. So it shouldn't be too crazy. Lecture checkoffs from here on out are going to be due every Friday night at midnight. They're going to include a code word from the lecture that's just going to be mentioned at some time in the lecture, as well as a screenshot of the demo code running on your computer. So basically, we're going to ask that you all download the demo code, make sure that you can run it, and also, listen out for that code word. All right, so starting this lecture, we're going to go with networking. What is networking? Simply the acquiring or passing of data to or from some URL that exists in the World Wide Web or even on a local server. Generally, the structures that you have to think about in relation to iOS are going to be the address, so the recipient address, the parameters, and the response. And I'll go over all three of these very shortly. Another term that you're going to need to know is API. If you're ever wondering what API stands for, it's Application Programming Interface. That's a pretty broad term. Essentially, it's an abstraction layer between any two software components, and it's used throughout all over computer science, operating systems, hardware, databases. You've definitely heard the term before. And APIs are awesome because they save you a lot of time, or ideally they should save you a lot of time, and ideally they should also be modular. APIs, when it comes to iOS, come in two different major forms. There are actual iOS packages, such as the Firebase package that you downloaded over CocoaPods. That Firebase package sort of embeds the API within it. It gives you a set of functions that you can use to push data to the Firebase application and pull data from it. So that's one form of an API. You actually download some Swift or Objective-C files. Another form, and probably a lot more common, is going to be using these RESTful APIs, which are called via a URL. And these APIs are not dependent on any specific language. You just have to make a URL request from any type of application, and it will return a standard response. So now into what are these RESTful APIs? Well, a RESTful API, REST stands for Representational State Transfer. Essentially, this is just a convention for APIs that use HTTP requests to get, put, post, and delete data. And those are 4 different types of HTTP requests. The vast majority of the requests that you will be making, unless you own a certain API, is the GET request. This basically just means you're going to be pulling data from some API somewhere that somebody else has. But also some APIs let you actually put data into their servers and do lots of other cool things. Requests will then return responses. And these responses can come in really any format. Really common ones are XML, YAML, and by far the most common is JSON. So an example of a request to a RESTful API, it'll look just like any URL that you've seen. So this one would be a request to the Google Maps Directions API, I believe. And the server would be maps.google.com. The resources, so sort of the location within the server that you want to grab your data from, will be all this stuff with the slashes. And the specific parameters, these are going to be basically how do you want the server to filter your data. So what type of data do you want? And all of this structure, the resources, servers, and parameters, would all be listed in the documentation for an API. And they all have different conventions and different styles, but this is a very common format. Is you'll have your server, and then the specific location for some specific data that you want, and then some parameters to filter out a specific subset of that data. And you could actually type in requests to a RESTful API in your browser. So simply typing out that URL and hitting enter, you can actually get a response, and it'll all be this text format here. And what is that text format? Hopefully you guys have heard of JSON before. JSON stands for JavaScript Object Notation. It is essentially the format that they use in JavaScript to define objects. And you can kind of think of it as a big dictionary. It includes keys, which are oftentimes strings, as well as values. So for example, this key ID might have this value, which is this big number encoded as a string in this case. And you can also nest more dictionaries within certain keys. So for example, this likes key goes into another dictionary with different parameters, first one of which being data in this case. So you can study JSON on your own time, but it's very popular. It's also very easy to send to or from different servers. It's language independent, even though it was created for JavaScript. There's support for JSON in pretty much every programming language. And it's also fairly readable by humans in terms of, compared to a lot of other formats. JSON is probably one of the most easy to actually read, especially when it's actually nicely formatted with all the proper indentation. So how do we actually do all of this in iOS? Obviously, we don't want to be typing in like REST requests into our browsers. So we can actually make a request natively in iOS using the URL request and URL session libraries. Or we could actually use third-party libraries as well. Alamofire is extremely popular. I think even Apple uses Alamofire for certain tasks. And that is a third-party CocoaPod that a team developed that, again, just handles a lot of the networking stuff for you. Parsing responses is the next step. So once you actually get that JSON back, you actually have to parse that into something that you can use. And iOS has a built-in library called JSON serialization, which allows you to convert JSON into dictionaries. There's also a lot of third-party frameworks for this as well. SwiftyJSON is another CocoaPod that's extremely popular for working with JSON. But in today's lecture, we're going to go over all of the native ways to do this. So using those built-in components. If you want to look up sort of those faster, easier ways using those CocoaPods, be my guest. A lot of people do. So now on to what a URL session is. So the relevant classes for a URL session, you're going to have a URL, and this is an object in Swift that contains a URL, usually as a string. You also have a URL session.shared instance, which is this singleton URL session object that's shared across your app. So this is a default object that you'll see in this demo. And also, you're going to want to add a URL session data task to that singleton object. And that'll actually create a specific task that will then retrieve the contents of a URL and then calls a completion handler when the request is complete. So first up, let's look at JSON encoded as a dictionary. This is a pretty common way of handling JSON, and it's going to be the way that we're going to do it in this demo. You could use this little line here, JSON serialization.json object with data, and this is going to be like literally a data object, and options are going to be just an empty brackets here. And you can add all these different types of JSON encoding options in here. There's a bunch of standard ones, and I think you can even make your own. You can then cast the result. So you'd store the result of this in a variable and cast that variable as a string to any dictionary. And so the keys from the JSON will be the strings here, and then the values will be of type any, and then you'll have to cast those consecutively. There's a lot of casting involved with this, as you will soon see. It's kind of annoying, but it does allow you to basically access JSON through dictionaries in Swift, which is kind of nice. Moving on, here is a pretty lengthy example, but we'll go through this line by line. This is sort of the basic structure that you're going to use for interacting with REST APIs. Imagine that the response from our server, so the JSON that will be sent to us, will look like something like this. It'll have the full name, an ID, and the Twitter URL for some user. And this is just arbitrary. We just made this up. Let's say that the URL that this JSON will come from will look something like this. Once again, we just made this up. And after we have our URL and we know the structure of our JSON that's going to be returned, we're going to go ahead and create a URL object. In order to do that, we'll write a guard let statement here, guard let URL equal, and this capital URL right here is the built-in Swift object for creating URLs. And it'll take in a string that represents the URL. And if this fails, the URL, if for some reason the construction of it fails, we will return. Because there are so many optionals involved with networking, especially using URL sessions, we're going to use a lot of these guardlets. If you used a bunch of iflets, you just have a bunch of indented code, and it would indent over and over and over again, and it gets really messy. So generally, when there's a ton of optionals involved, we'll just use a bunch of guardlets. After we have our URL object, we're now going to reference that URL session.shared singleton that I was talking about. And this is, again, the shared session that all of our data tasks are going to go to throughout our app. We don't have to do anything to create this. It's already created for us. And we're going to add a data task to our session. And to do that, we simply run .datatask. We pass in a URL object. And if you remember, when a closure is the last argument of a function, we can actually just omit writing a last argument and put the closure just in brackets or in braces right after our function call. If you don't remember this, don't worry about it. But basically, we're going to have this closure here that we also pass in as an argument to this function. And a closure is just another way of writing a function. So basically, we're passing in a function to this data task, and this is our completion handler. So this function is going to be run as soon as this data task is complete. So basically, as soon as it gets a response from the URL, which is going to contain our JSON, it's going to call this function. And what does this function do? Well, it takes in data, a response, and a potential error. So these are the three parameters of our function. And again, this is just Clojure syntax. And the lines of our function, we're going to go ahead and unwrap the data object. So we'll run a guard let on, we'll call this user data. That's because data isn't optional here. You might also want to check the response. We'll make sure that it's a 200 OK and not a 404 or anything like that, as well as any URL errors that might be thrown. In this case, we're just going to assume that everything's good. So we will unwrap our data object. We will now use the built-in JSON serialization library to parse all of this JSON into a dictionary that we can actually use. So to do that, we can go and run this little try statement here. That basically means that this can potentially throw an error. You can also have a catch block just in case an error is thrown. This is pretty conventional in other languages too. And the line that we're going to use is JSON serialization dot JSON object. And in this JSON object constructor, we are going to pass the user data and options for our JSON object. And the user data, again, is just this data here, which is just the unwrapped data that's passed in from our response. And options, you can learn more about JSON serialization objects if you want. It's just different ways of actually parsing this into our dictionary. We're just going to leave it blank. Now we have our JSON object. This is this built-in Swift JSON thing that's kind of abstract. We want to actually, access this data here. So we're going to cast this JSON object as a dictionary. To do that, we can just run something like guard let dictionary equal JSON as a dictionary from type string to any, else return. So again, this is going to cast this from a dictionary of type string. And because there are multiple different types that are multiple different value types, so here we have a string, here we have an integer, for example, and here we have another string. Because of that, we need to make this second type any. If we knew that all of the value types were going to be of type string, we could cast this from string to string, or if they're all integers, we could do string to integers, etc. But because there are multiple types, we're going to use any. Now we have our dictionary representation. Now another guard let statement, because we have another optional. We're going to try to get the full name. Oh, this should actually be full name, not name. My bad. But we're going to try to get this name out of this dictionary. So we can write guard let name equal dictionary of, imagine this is full name, just like that. Oops. Else return. And this, if all of this worked well, then this name variable will be RJ Pimentel as a string. And now say we have this last line that updates some label in our app with that name. So something that updates the UI. And at the end of all this, if that's not enough, this thing is kind of getting in the way, but you can see we have a dot resume here. I'll let that disappear real quick. So at the very end of that function that you define, you have to hit dot resume. That's actually going to start this data task. And the reason why this exists is because some data tasks can go on really long, and you can pause them or resume them if they're taking a long time. But you have to run dot resume to actually start it, and then all of this should work. So again, you have to kind of think about this. It's going to take a while for this URL request to come back. So it's going to run all this other code in the meantime, updating the UI in different ways, letting you scroll and tap things. But all in the background, it's going to be processing this data task, and it's going to run this little function block here as soon as that data task is complete. A side note, so very, very often people will try to update the UIs within a Clojure. The thing is, so this again, self.update label with name, just imagine this is some function that we wrote that updates a label. Swift actually performs these closures on separate threads. And the problem is only the main thread can actually interact with the user interface, or only the main thread should interact with the user interface, I should say. This, in the olden days, this would be a complete crash of your app, and I think it still can result in a crash of your app, but most of the time it'll just throw you a really ugly error message saying, why are you updating the UI on some background thread? That's inefficient and bad. So basically, whenever we're updating the user interface within a closure, we're going to want to force that line to run in the main thread instead. And the way that we do that is by this little block of code, one of the most infamous / legendary blocks of code in iOS, I would say. This is dispatch-queue.main.async. And all this is going to do is run any code that you put inside of it, force it on the main thread. And again, if you don't know what I'm talking about, if you don't know about multi-threading or anything like that, go ahead and ignore what I'm saying. But regardless, if you want to avoid errors when you are trying to update the UI in a closure, just put everything in this little dispatch queue.main.async. And you will see this very, very soon in our demo. One last thing before we go into that demo, you can actually process JSON as a struct. And what I mean by this is you can imagine you have some model class. So if we go back here, imagine you had some model class, say user, that has the parameters full name, ID, and Twitter. So it looks just like the structure here of the JSON. You could have your own structure object that, again, will extend the decodable protocol, I believe, and it'll conform to, again, the fields found in the JSON response. Basically, you define your own struct that looks like the JSON. There's a way to sort of automatically map that JSON into that struct, which is pretty useful. I won't go into it, but if you're interested, there's a really cool little example tutorial here. It was a thing that was added in Swift 4 kind of recently, so go ahead and explore that. It allows you to avoid all of those crazy optional unwraps all the time when you're trying to use these as dictionaries. With that, sorry, that was a lot of information, but let's go ahead and see a practical demo. So for this demo, I decided to build something pretty relevant to all of us, and that is going to be a little chart that tracks our total COVID-19 cases since January 21st. And right now, this is showing data in the US and showing active cases, and we'll be able to modify those different data points or different countries, and I'll show you how to do that. But you notice you can rotate this, and this cool little graph CocoaPod that I downloaded will also be able to adjust however you want. So let's go into it. I've just created a brand new project here that I called Coronograph, and it's completely blank. Let's go ahead and just build a little UI here. So I'm going to go ahead and add a label to the top. I'll just fast forward configuring this real quick. All right, this label looks pretty good to me. So now for our actual graph view down here, we're going to want to install a CocoaPod, specifically the Charts CocoaPod. And you could look this up. They have a GitHub page with all the documentation and everything for it. But I will skip over those steps because this is not a lecture about charts. But let's go ahead and install it anyways. So remember, whenever you're installing a new CocoaPod, you need to open up your terminal, navigate to the directory of your project. In this case, it's the Coronograph project. And you run pod init. If we open up this folder, you'll see after we run pod init, there is this pod file that is created. We double click the pod file. Underneath pods for Coronograph, we'll write pod, and in this case, it's called charts. We'll save this, we can X out of it, and we run pod install. Now this will create a bunch of stuff for us. The most important thing is this XC workspace file. Remember, right after you run pod install, close any XC proj files or close any of the projects that were open using this. And now every time you're going to open the project, you're going to want to open the XC workspace file instead. And this XC workspace file will have our pods already configured for us, so we can just use them right away. And charts, like many CocoaPods that involve a UI element, require you, if you want to use storyboards, to create a UI view in your storyboard, which is the superclass for all of the other UIKit elements. By itself, a UI view is just a blank square, but when you make it a actual subclass, so if you go to the identity inspector, you go to class, and you set the class for this UI view to actually be, in this case, a line chart view. And we have this line chart view because of the charts pod that we just installed. Now, when we run this, this will actually be a chart in this box. But let's go ahead and set some constraints for it. We'll do 10 on each side. Add 4 constraints. Nice. Now we can create an outlet into our view controller. So I'll just control drag, and I'll call this chart. And you'll see I already imported charts up here at the top of the view controller. Otherwise, this will error because it does not know what line chart view is without importing charts beforehand. After this, I have some chart setup code that I just got from looking at a bunch of sample projects. You do not have to really understand this, but if you want to, go ahead and look through it closer or go and find the documentation for this CocoaPod. But I'll just go ahead and paste it here. And it's this function setup chart. See, I have some commented stuff out on the top. We'll get to that in a bit. But this just goes ahead and configures a bunch of our chart data and appearances. So it just sets the axes, sets the spacing, all that kind of stuff. Now let's go ahead and go to the meat of this demo, which is going to be actually interacting with a REST API. So the API that I found, it is at this address, corona.lmao.ninja. If we just go to this site right here, it'll take us to the GitHub for this API, and it'll have some more documentation and some more info. So if you want to explore that, go ahead and do that. But for my purposes, I'm going to this specific request to this API, which is returning historical data for the US. And the format that comes out, this should be familiar. This is all JSON, just like many APIs. And we can see we have some key value pairs, country, provinces, which is blank, and then timeline, and it'll give us dates and case counts at those dates. And we could type in a country code for lots of different countries, like Italy or South Korea. So there's tons of different options. You can see how all these countries compare if you want. But for our purposes, we'll stick with the US. Now back to our iOS project. We'll go ahead and create a new file. And it's going to be our model file. I'm going to call this Corona data. And we can X out of this storyboard. All right, great. Now we'll create our new class. We'll call it Corona data. And our Corona data is going to consist of 2 lists of information, or actually really 1 dictionary of information. We're going to have that be, what should we call it, date to cases. So I'll say var date to cases equals, it's going to be a dictionary from type string, which is actually, sorry, from type date, which is going to be the date representing the different measurements from that API. And it's going to go to have a value type of an int, which is going to be the case count on that date. And we can just initialize that like that. Great. Now it's time to actually write some networking code. So we can write a function here. I'm going to call it refresh. And this function refresh is going to be called whenever we want to refresh our data. So to start, let's go ahead and write down the URL that we used earlier. Say URL string equal this URL, which is going to return our JSON. Next, let's say guardlet URL equal, and we're going to make this actual URL object. Again, this is a class in Swift already. It's going to take in a string, and it's going to be URL string. Else, we will just return. Next, we are going to actually create our sort of data task. To do that, we do URL session dot shared dot data task with the URL, and then open brackets. We have three parameters that we're going to put into this closure here. 1 second, let's bring this parenthesis back. We want data, the response, and the error. And then again, closure syntax, we write in, and then now we write the body of our closure. So remember, we can sort of ignore this response and this error. In this case, in a production app, you'll probably want to read these and make sure everything checks out. But for now, let's just go ahead and say guardlet corona data equal data, else return. So data is an optional, but if we get the data, let's bind it to a variable called corona data. Then let JSON equal try, and we'll do this sort of try syntax because this next line can throw an error. Serialization dot JSON object with, and it's going to be corona data. The options for this are just going to be an empty array for now. If you want to get into these options, you can go ahead and look those up, but not super important for us. Now, with this JSON object that's returned from this, we can actually directly cast this as a dictionary. So let's go ahead and do that. Guardlet dictionary equal JSON as, it's going to be of type string to any. And if this doesn't work, just like before, we will return. Cool. So now we have this dictionary that is represented by our JSON. Now we actually have to look at the structure of our JSON response in order to go further. So if we go back here, we can see we have, first of all, we don't really care about the country or provinces. We care about the timeline key value pair here. So first of all, let's try to see if we can get this out of the timeline. So we'll say guardlet timeline equal dictionary of timeline, else return. As this is also going to be of type string to any. Great. So that should give us the timeline object or timeline dictionary. Now let's see after this, then we actually want the value for this key cases here. If we used deaths, we can get the death toll by each day. And there's also recovered, which gives you the total number of recovered patients each day. But in this case, let's just use total active cases. So guardlet cases equal timeline of cases as. And in this case, when we go into cases, we can see these are strings to integers, actually. So this should be able to cast as a dictionary from string to integer. Else, we will return. Great. Now let's go ahead and iterate across all of these active cases. So we can actually write a for loop to iterate across every key value pair. So we'll say for date, comma, count in cases And now we actually run into this interesting issue, which I did not anticipate going into this project, but because dictionaries are unordered, instead of, they really should have put this all in an array, but they put it in a dictionary, which means, or, in this bracket notation instead of or braces notation instead of a bracket notation. Anyways, basically this is an unordered collection, and we need all these dates ordered. And the only way to properly order them is to actually convert them into date objects and sort them. So let's go ahead and do that. Anyways, this is going to iterate across every key value pair. Let's let our formatter, you don't really need to know this, but it's kind of good to know. This is how you do date formatting in Swift. So we can create a date formatter object. We can set the formatter's date format equal to, and in this case, the format is going to be capital MM/DD/YY. You can look up the Swift and Objective-C date formats, but this is the one that you would use in this case. Lowercase m is minutes. I've made that mistake many times. Uppercase M is month. So that is going to be our date format. Now we can actually construct a date. So we can say let date equal formatter dot date from a string. See, this is super cool. Basically what this does is allows you to create a actual date object just from a string representation. And that string representation is going to be this date that we passed in here. And then now let's go ahead and set self.dates to counts of that date equal to the count value that was passed here. Cool. So what this is going to do is it's going to iterate across all of these cases, store these strings as dates, these integers as integers, in this date to cases dictionary. Cool. Oh, and this is optional, so we can just force unwrap this because I know it will succeed every time. Okay, great. Now, after this, we're going to close out our closure here and hit .resume, which is just required to actually start this data task. And it looks like we have an extra bracket. I'll go ahead and just delete that there. Whew, that was a lot of stuff, but we're not done yet. So it turns out the actual chart, the charts CocoaPod and the chart view here requires a very specific type of data structure. So I created a function called toLineData that handles all of that. I'm just going to paste it in here, and here it is, toLineData, and it's going to return something called line chart data, which we cannot actually access until we import the charts library. Okay, great. And oh, instead of dates to count, we called this date to cases. Cool. And that should be good. One more time, date to cases. Great. So this will, again, you can look through this on your own time, but basically all it's doing is creating this line chart data object, which we need to use to actually display. But for all intents and purposes, this data is accurate. And we also, in here, I guess it's important to mention, we sorted all of the keys by date, because remember, dictionaries are unsorted data types by default. Cool. So this toLineData function should work. Everything should be good. If we go back to our view controller now, we probably want to actually now access our data. And so again, this is using a model that we do not have yet. So let's create a variable corona data, which is going to be of type corona data, and it's going to equal, actually we don't even need this type, it's just going to equal this corona data object. Cool. Now this almost works by itself. First of all, we probably want to refresh the data and actually set up the chart in our view did load. The only issue is, and this is really important, When we call this refresh, this is going to take some time. It's going to have to go to that URL and actually execute this data task. And the whole reason we put all of this in a closure is because that's going to take a lot of time. If our whole program just stopped while this data task was going on, then everything would freeze until we got a result back, which if it was downloading a big file, would take a really long time and our app would be frozen for a really long time. So instead, we're actually running this asynchronously. This task is going to be executed, and on a different thread, if you don't know what multi-threading is, don't worry about it, but on a different thread, this closure is going to be executed. And basically, it's going to be in parallel with the UI thread, and we don't actually really know when this is going to be executed. So our issue is when we call this refresh, it's going to take a lot of time to start downloading the data. In the meantime, it's going to call this setup chart function, and our chart will be displayed in all of its glory, except the data will be empty. So we have to set something up so that this refresh function will actually call setup chart when it's done. So to do this, one kind of nifty way is to actually create a different completion handler within this refresh function. So basically, we can just go ahead and make another argument. Let's call it completion. And it's going to be a closure. So it's going to be a function from no arguments, and it's going to have no return type, but it's going to be some function that we want to call. And in here, we can go ahead and then at the end of this closure, at the end of this data task right here, basically this is after all the data has been downloaded, we'll call this completion function. But you'll notice there's an error that will come up right here. Escaping closure captures non-escaping parameter completion. Now this is another really interesting part of Swift and with asynchronous programming in general. So basically, an escaping closure is one that executes after this function actually returns. So this data task will be executed. It's going to work on its stuff beforehand. In the meantime, this function is going to return, and this stuff isn't going to get called until after this data task is complete, which is going to be way down the line. So that's called an escaping closure, and we're going to add this @escaping here in front of this closure type, and that'll tell the compiler that we're actually going to call this completion handler outside of this function. If you want to learn more about this, it's a pretty fascinating topic. Go ahead and just look up escaping closures, and you'll find a lot of information about it. But basically, we can go now back to our view controller, and in this refresh function, we can now pass in a completion handler. Remember, when the completion handler, or when a closure in general, is the last argument, so it's the only argument of this function, we can just pass it in brackets after the function call. So that's what we'll do. So here, we're going to want to call setup chart. And we can actually delete this in the meantime. So now let's run this, see what happens. Oh, sorry, self.setupChart. Another interesting part of using closures is you'll always have to reference self whenever you want to access some method or property in the outer class, just a closure thing. And you look at this, beautiful. This whole graph displays. We can rotate it. It looks fantastic. Going back here, we also notice though, as I mentioned before, when UI elements are edited off of the main thread, we get a bunch of nasty errors. And that is exactly what these are. These are basically saying, oh my gosh, you're modifying the UI on a background thread. What is happening? This is bad. And it doesn't actually crash our app. In this case, it's actually pretty okay. But for best practice and to make sure this doesn't crash in the future, we're going to run that line that I mentioned in the slides, dispatch queue.main.async, and run this setup chart right here. So this will force the setup chart function to be ran on the main thread, which means that the UI, in this case this chart, is only going to be modified on the main thread. Cool. So we can go ahead and run this again. And we'll see initially it says no chart available or no data available because the data hasn't actually been retrieved yet. But as soon as it has, this whole data comes in, and again, we can rotate this. And that is our whole demo here. Also notice these are days since January 21st on the bottom here. These are total counts here. And if you want to actually like modify these data calls, we can go ahead and, for example, look at Italy by just changing our URL here. And we can see that Italy is way up here, but they are just starting to beat or flatten the curve, as they might say. So hopefully that trend continues. And I also want to mention the key phrase for this lecture is going to be @escaping, all one word, all lowercase. That is going to be the code. With that, let's go back to the lecture where Nick will take over.